Okay, good morning. First of all, I would like to thank the invitation to be here, Auguste and Margarida, for organizing this symposium. It's a pleasure for me to be here. And I'm going back to faces more than sounds. I think, departing from an evolutionary hypothesis, we can think that our cognitive basic functions, perception, memory, thinking, have evolved through ages as a consequence of natural selection and environment contingencies. And this is related to the fact that stimulant situations that have been relevant to survival have acquired capacity of activating more efficient information processing mechanisms in order to allow us or to prepare us to adequately deal with the environment threat. So, from an evolutionary perspective, there is a clear survival value in a quick detection of threatening stimuli. And there is a lot of studies that have proved that, have shown that, mainly using classical animal fear stimuli. Snakes and spiders have been the most used fear stimuli. And different kinds of methodologies, but one of those that have been used is the visual search paradigm, in which you can show an array with different stimuli, and one of the pictures can be different from another category than the others. For example, you can show some mushrooms, and you can show a snake within, or you can show more stimuli, and you can show a spider, for example. And the paradigm is very easy because you just need to say if all belong to the same category or if one is different from the others. So you don't need to recognize what it is, you just need to discriminate one different stimuli. And using this kind of paradigms, it has been shown that, for example, snakes and spiders are detected more rapidly and more efficiently with few errors than, for example, mushrooms. So depending on the number of distractors, it takes more time if you have more pictures, but in general, snakes are always faster and spiders also faster, and mushrooms slower in this case. Interestingly, also if the exposure is very brief, in this case we only use exposures of 150 milliseconds or 300 milliseconds, and even though we could see this pattern, that was easier, fast detection of the snakes and the spiders than mushrooms. So this is what has been obtained with the different kind of fear stimuli. But what about emotional facial expressions? Well, one interesting approach to this is the approach that Ernst Mayr introduced when he classified fear in 3 different kinds of threats. Fear related to physical environment, fear with interspecific contexts and interspecific contexts, which is related to the phobias that we have phobias related to natural phenomena, thunder, height, spaces. We have phobias related to animals, as I just referred, snakes and spiders, for example, and social phobia related to interspecific fear. So from this, we could think that unpleasant facial expressions should be an important category of threatening stimuli. However, the recognition of emotion in the face, the recognition of facial emotional expression is more complicated. And Auguste has already talked about it, that you can think about emotions in this kind of categories, that you have specific features that you can identify, and you can have this kind of facial effect program. For example, Paul Ekman was one of the main theoreticals in this field, that you can, from different features, identify emotions as categories. Or if you think of emotions more in a dimensional perspective, like the perspective that Jim Russell has, the circumflex model of affect, that you can think in 2 basic dimensions, some kind of emotional valence, pleasure, displeasure, and arousal. So in this case, it's not that you have specific entities, categories, that are identified as specific emotions, but more that there is combinations of pleasure, displeasure, and low and high arousal. But if you think about emotions as specific, discrete categories, well, the literature is quite complex, and Augusto already talked about it a little bit, but there is some evidence of prototypic, or that prototypical facial expressions can be recognized. And this evidence, you can see both behavioral evidence, that you can ask how much accordance, agreement there is identifying different emotions. And as Augusto also said, if you have 60% agreement, you have 40% disagreement. So the agreement is not perfect, but there is some general agreement in the identification of facial expressions. And there is also neurophysiological specificity, that specific emotions can activate specific areas, which, well, is interesting because it should imply some kind of discrete, the evolution of discrete categories identifying emotions. However, there are some methodological problems, and basically, one problem is that the faces used in these stimuli, in these studies, in these experiments, are always prototypical, which are very, sometimes exaggerated expressions. And the other main problem is the use of a forced choice responsive procedure, that you have different labels that you should see from a specific face, for example, which label corresponds to that face. And that increases the number of agreement. So this is a general problem that has been obtained with these prototypical facial expressions, although there is some evidence on this capacity of identifying emotions. However, when we use more spontaneous, more natural stimuli, well, the results are different. And this is already, you have already seen this picture that Augusto presented, and you can see that, okay, happiness is the best one, but even there, it's only about 20% of agreement, so it's very low and not at all comparable with the results with prototypical facial expressions. And also, when you have an open response format, that means that you don't just have labels to choose between, but you can just say, what is this face, for example, then you can see that the answers are much more complicated and much more variety in the answers. And, for example, that you can see the same face implying different emotions. So the use of spontaneous natural stimuli really shows that it is not that easy as it might seem from part of literature using prototypical emotions. However, one interesting thing is that these are studies using recognition, and recognition implies some kind of comparison with some kind of correct emotional category that is defined a priori, that we say, okay, this is an happy face, and how many of the participants are going to identify this emotion as an happy face. And in this situation, if you use this kind of prototypical expressions, we can say that you have a good ability to recognize different emotional expressions, even in conditions of reduced perceptual information. For example, if you have backward or forward masked, or if the pictures are blurred or short exposure, we are quite good in it, although, again, it's not perfect, and we have always this, the idea that if you have a percentage of agreement, you have also some big percentage of disagreement. And then you have that some expressions are easier to identify than others, and happy faces are always easier to identify, independent of the study. In all studies that, I guess, all that have been published, if you are just comparing the rates of correct identification, happy faces are always better. And then there are some cultural differences, although there are some cultural similarities, but there are differences, so there is some kind of space for the influence of the environment in this capacity of recognizing facial expressions. However, if you go from the recognition to the detection, the question is another one. And for already many years ago, Hansen and Hansen did an interesting study in which they used the visual search task in order to see if it was easier to detect discrepant happy face or angry face. So they presented 9 or 4 photos of different faces. And again, the task was only to say if all belong to the same category or if one is different. And then their main result was that it was easier, that the participants were faster detecting the angry face among the happy ones than the other way around. And they call this the anger superiority effect, that threatening faces popped out of crowds. This study was interesting, and it was influenced a lot of subsequent studies, but there were some problems, some methodological problems, but also that it's difficult to separate the perceptual characteristics from the effective information. How much is the effective information conveyed by the picture, or how much is just the perceptual characteristics? And in order to try to answer this question, Eman and collaborators did a series of studies in which we tried to reduce the perceptual differences. For example, in this case, we only manipulated the eyebrows and mouth in order to see if with this kind of schematic faces we could get similar effects and some kind of easier detection of threat, and not so much related to the perceptual characteristics of the faces. And the results in this series of studies were quite consistent, that it was always easier to detect the threatening target compared to the friendly one, although it doesn't seem very big difference, but it is significant, clearly significant differences. And of course, when there were no target, when all faces belonged to the same category, then it was, well, much longer time to say no, and more depending on the number of pictures in the array. Another study used this kind of combination of eyebrows and mouth in order to see which feature were more important. And you can see to the right the typical angry face. That was the faster one to be detected. And the typical happy, the one that took longer time. But interesting, you have this kind of, the second one, some kind of, although the mouth is smiling, is some not so smiling, or some kind of, strange face, which also was somehow in between. Okay, but from these studies, we thought that, okay, but if we have this detection of, if we have this ability to detect facial expressions, threatening facial expressions very fast or faster, or if this is something that we have developed, then it could be related to social anxiety. That means that people who are social anxious would be better picking up these cues and better discriminating this or detecting these angry faces. Well, we did a series of studies, and we did it both in this classical way, but even threatening with false feedback and by other means trying to increase the social anxiety in the participants. But the results were quite deceptioning, because we didn't get difference. In general, we got this difference between the friendly and threatening faces, that threatening faces were always faster to detect in these arrays, but no difference between high and low social anxiety groups. So it doesn't seem to be just that ability, but something more general, that we have this general ability to detect threats in the faces. So, to conclude, I say that we can say that faces convey crucial information in social contexts, and facial expressions reveal something about the intentions of others. Well, this can be discussed, but it should be something about if the others have some kind of threatening or friendly intentions. and that you have, in general, developed a great facility in perceiving emotional expressions, and more specifically, to detect the threatening emotional facial expressions more efficiently. That means faster and more accurately. And this should theoretically give us the possibility to be able to react quickly when in social contexts, when we are facing threatening faces. So I will finish now, and I hope I will get more happy faces than threatening faces from you. So thank you very much for your attention.